Hello sir, in this video lecture I am going to explain op amp as an active filter and the types of op amp. First let us see what is an op amp. An op amp is a high voltage electronic voltage amplifier. Its input is the difference of the input of the dipoles. Its output will be at 1 n. It is the diagram of the op amp. Here plus is the non-inverting terminal, minus is the inverting terminal, and output is given at the apex. Let us see op amp as active filters first. What is a filter? Filter are circuits that are capable of passing signal within band of frequencies while rejecting or blocking of signals of frequency outside the band. This property of filter is called frequency selectivity. Then let us see the types of filter. There are two types of filter, passive filter and active filter. Passive filters are the circuits that are built up of RC, RL and RLC. RC, RL and RLC are nothing. R is the resistor, C is the capacitor and L is the inductor. Active filters. Active filters are the circuit that employs one or more op amp in a design in addition to resistor and capacitor. Then types of active filter. Filters may be analog or digital filter. Analog filter processes continuous time signal. Digital filter processes discrete time signals. Analog or digital filter is subdivided into four types: low pass filter, high pass filter, band pass filter and band stop filter. In an active filter there is no inductor. It have op amp, resistor and capacitor. It provides arbitrary gain. It is easier to design, easy to adjust over wide range of frequency. Low output impedance prevents the filter from excessive load. High input impedance prevents excessive loading of driving source. The active filter has both advantages and disadvantages. First, let us see the advantages. Active filters are used in communication and signal processing circuits. They are also used in entertainment and medical, electronic, etc. Then disadvantages. Limited bandwidth of active devices limits the highest attainable pole frequency and therefore application nearby 100 kHz. Requires power supply. Increased sensitivity to variation in circuits parameters caused by environmental change, unlike passive filters. First, let us see active low pass filter. Filter that passes frequencies from 0 Hz to critical frequency Fc and significantly accentuates all other frequencies. Ideally, the response drop abruptly at critical frequency Fh. It is the diagram of the active low pass filter, and here it is the graph of the active low pass filter. Then active high pass filter. Filter that significantly attenuate or reject call frequency below Fc and allow frequency above Fc. Ideally, the response rise abruptly at critical frequency. Then active bandpass filter. Filter allows all signal lying within band between lower frequency limit and upper frequency limit and essentially rejects all other frequency that are outside. Bandwidth is difference between upper critical frequency and lower critical frequency. Then active band stop filter. Filter which operation is completely different from band pass filter because the frequency within the bandwidth is rejected and other frequencies are passed. The bandwidth is the band of frequency between the 3 decibel points. We have finished the op amp as active filter. Now let us see the types of op amp. There are 6 different types of op amp. They are inverting amplifier, non-inverting amplifier, summing amplifier, subtractor, differentiator, and then integrator. First, let us see inverting amplifier. In an inverting amplifier, output is given to the negative terminal, that is the inverting terminal, and input is given to the negative terminal, that is the inverting terminal, and positive non-inverting terminal is grounded. And here there is a feedback given to the output terminal from the input terminal. Here R1 is the input resistance and R2 is the feedback resistance. Then voltage gain AV is equal to V0 by Vi is equal to minus Rf by Ri. Then non-inverting terminal, here the inverting terminal is grounded and input voltage is given to the non-inverting terminal. Then there is a RF, there is a feedback terminal given from inverting terminal to the output terminal. Here RF is the feedback resistance and Vin is the input voltage, V out is the output voltage. Here voltage gain V0 by Vi is equal to 1 plus Rf divided by Ri. Then summing amplifier, this is the diagram of the summing amplifier. Here V0 output voltage is derived. Then subtractor, it is the diagram of the subtractor. Here it is given, the output voltage is given. Output voltage is equal to V1 minus V2. Then differentiator, it is the diagram of the differentiator. Then it is the graph of the differentiator. And then integrator, it is the diagram of the integrator. And then logarithmic op-amp. Here IF is derived. IF is equal to Is e to the power Vf divided by n Vt, where Is is the saturation current of the diode, Vf is the voltage drop across the diode when it is forward bias, Vt is the diode's thermal equivalent voltage, and it is the output voltage derivation. Output voltage V0 is equal to minus n Vt In Vi divided by R1 Is. And it is the anti-logarithmic op-amp. It is the diagram of anti-logarithmic op-amp, and output voltage V0 is derived. V0 is equal to minus R of Is e to the power Vi divided by nVt. And it is the comparator. It is the diagram of the comparator. Thank you.